Hey, hello everyone. Thank you so much for joining our session on how to build AI agents and apps in minutes. This is going to be a packed 1 hour session. We'll cover both theory and practical tips on how to get this done. So the goal is basically how to accomplish a very simple goal, how to build AI agents and apps. What I'll cover is what is an LLM agent and disambiguate the hype from reality. And I think that will be a helpful starting point. From there, we'll talk about how do I actually build a LLM agent from scratch. From there, we'll go into BAI, which is the project that I've been working on for almost a year and which offers the tooling that helps you accelerate your journey on building AI-powered agents and apps. And then we'll move into more hands-on code. So here I'll show you how to get started with the B framework, how to build your own custom agents and apps. And then I'll try to leave about 10 minutes at the end for questions. So yeah, someone is going to be helping me get questions from the chat and curating them for me. So that's more or less how this is going to pan out. For the hands-on section, what I would recommend is to watch what I do today, and then I will be sharing a link for all the code snippets and the tutorial I did. So if you want to recreate this later today, it will be really easy for you to grab everything and get started from there. Yeah, I think in a virtual format, it might be difficult to present and then code and have someone code at the same time. So I'm hoping this works for the best. I'm used to giving this format in person. So let's try this out. Okay, before I dive in, just wanted to introduce myself. My name is Maya Murad. I've been with IBM Research for about 3 years now. I have the role of technical product manager. That means I bridge the gap between some of our cutting edge research in AI in different fields and how to make these technologies useful and usable to a broad set of users. So I've been working in this space for a while. I love being the person that bridges different research professions together, different disciplines together. And yeah, I just love being at the intersection of all of this. I'm quite active on LinkedIn. I share their tutorials and materials, so feel free to follow me there. Less so on X, but I put my handle just in case. Okay, let's get started. So what is an LLM agent? And to tell that story, I'm going to talk a little bit about my own journey in AI. So first of all, it seems that the term AI agents is new and it just popped into the scene about last year, and it's all that we can talk about. But this is quite an old concept if you think about it. So the origins of agents can be traced back to the origins of some of the first thinking around AI and algorithmic systems back in the 50s. And if we're going with the very broad definition that stands the test of time, I think a good definition here is it's a system that can autonomously interact with a designated environment in order to accomplish a certain goal that it's prescribed. So I used to intern at Unity Technologies, and when they talk about, at the time, I think in the last decade, when they were talking about AI agents, what they meant is agents that were powered by reinforcement learning, and these agents could basically play within a game, in a simulated game. They have an action space, which is the legal moves in that game. If you're playing a board game, that could be moving back and forth. And they basically learn by trial and error. And they're able to self-improve, and can they get these agents to play thousands of games in order to learn at scale. So even the technology that powered AI agents has shifted over time. So we've moved from supervised learning and reinforcement learning to what we're now calling LLM agents. So now if you're hearing about AI agents, we're actually talking about agents powered by large language models. So the new definition I would give here, the definition of what we mean by an LLM agent, is one where the large language model is the one who's executing the logic of the program. So let's say a user comes in with a goal, help me plan my trip. The LLM would decide what is the best way to solve the user query. And it would do so by usually following a multi-step process. And it has this model, an agent has at its disposal tools. So tools are external pieces of software that allow you to interact with the external world or internal systems. So the most common way of interacting with external systems is like accessing data or accessing a database. So that is called drag, but that could also be a calculator, an HR system, another model, some chart building capabilities. So it's kind of giving superpowers to the model that it doesn't have inherently, but also the model can call itself. So if you're trying to summarize something or translate something, most models have those capabilities built in, and then it can call itself. And so not only that the model acts, some people like to say the brain analogy. I try not to anthropomorphize that much, but so not only does the model plan, it can also see the outputs on interim steps, and then update its plan based on that. So if you think of yourself as someone who codes, and then often you're running code and you hit an error, and then it might say you're missing a package, there's a port connection error, etc. Most models are able to debug themselves. So if you specifically prompt that model to reflect on the error and try to get itself unstuck, it will probably be able to update its original plan in order to avoid those errors. And that's exactly what this loop is here. And what is great here is you're able to go after much more complex problems with less touch points. So this is kind of a really high level view, but we'll go deeper from here. Yeah, why is it a game-changing technology? Because we're able to go after much harder problems. So that it will be easier to tell the story if we talk about how we went from standalone models to LLM agents. So 2 years ago, large language models burst on the scene. I think they changed our expectations of what AI could do and how impactful it can be in a conversational modality. So in 2 years ago, if you remember just interacting with ChatGPT, for example, all you did was talk to a model and the model return an answer, and kind of that was it. It was a kind of a one-step process. So that was useful for a lot of stuff. I'm sure that's why ChatGPT took up. But some of the limitations here is the model doesn't know you. It doesn't know facts about you. It cannot personalize its answers. It doesn't have access to up-to-date information. So if I ask it about the weather today, it will likely hallucinate an answer because these models are biased towards completing the sentence. And yeah, so lots of interesting, but there are limitations. And the next wave of how we interacted with models were how do we make them useful and plug into our own systems. So some of you might have heard of retrieval augmented generation. In short, it's a way of avoiding the limitation of the knowledge limitation of models and giving access to models to external data sets. So let's say you have your own product documentation and you want people who have questions about your product to talk to a chatbot about it. And let's say you're constantly releasing new features and these docs are constantly updated. It's not economically viable to keep retraining a model so it has the latest information about your product. What you would want to do here is first give access to your model to a database where that product information is stored, so that whenever user query comes in, you would first kind of shortlist relevant data that the user might find, and then get the model to generate a nice targeted summarized answer that is tailored for what that specific user is looking for. So from a technical standpoint, what we're looking at here is a fixed flow. So this is a multiple step process that was pre-designed by the builder ahead of time. And the key difference here with an agent is that the steps that the agent should take are not strictly defined at the beginning. The model has agency to determine how to execute the problem it's given and how many times it can loop in order to give a final answer. So if we're really talking about what changes here, it's the ability to control the flow of the program. And these three approaches are still valid. There are certain use cases where it's definitely faster and more economical to just talk to a model directly, input output. If you have a very fixed flow and little degrees of freedom, again, you're going to get more consistent results with the second approach. The third approach is interesting when you're going after much more complex problems where you want to automate them further. So you want to kind of go further in how much the model can solve on your behalf. and where usually there would be some human in the loop, because in the agentic world you're giving up control, so the results might not always be aligned, there might be mistakes. I think fully agentic approaches might be more popular once we get better models. But I think what I'm seeing right now is most of the applications that we're seeing are somewhere in between fixed flows and fully agentic workflows where the model's in control. And I'll talk more in detail about these like workflows later on. So I wanted to showcase this video quickly. For some reason, I can't get it to play. But IBM recently launched a demo of a software engineering agent. So this is, I can later post the YouTube video for this. This is basically an agent that you can deploy on a GitHub issue, and then that agent will come up with a plan of how to solve that issue, will write the code for it, and then submit a PR. So this is really a step change of what we're able to do, because in the previous modalities, we used to chat with a model and then say, oh, I'm kind of blocked here. Can you help unblock my code? And now we're able to just give the issue and the model solves it end to end. It might require some human inputs to get unblocked, but this is kind of the promise and why there's so much hype around it, because like we're taking really complex workflows and kind of automating them end to end. Now, just the speck of reality here is that the SWE benchmark, I think maybe the top performers are getting 30 to 40% maybe of all issues right. And then these are pre-curated issues, so we don't know how well it's going to generalize on new issues. So, I mean, even though it's able to kind of go end to end on a difficult problem, you still need a human in the loop to review the outcomes that you're seeing. So the best analogy I have of what we have with this current technology of agents, it's an intern. It's an intern that might help you take a first stab at a lot of things. It might help you solve a lot of issues and your pain points, but you're always going to have to be careful to review their work before you submit it to your manager, for example. And I'm gonna also, the picture is not so always so rosy. I want to talk about the challenges that this technology brings. The way that I like to describe it is agents is building on top of imperfect technology, which is LLMs. And LLMs are brittle. So I'm sure you're familiar, they hallucinate. Small changes to a prompt can completely derail them. So if you see this example here, the only thing that changes is A or B changes to I and two I's. And for some reason, because of some idiosyncrasies on how this model was trained and what data it saw before, that trips it up, and then the final answer gets completely changed. Now, we're using this large language models, and we're having it iterate so many times on itself, where that can lead to small changes like an extra space, a dot, some difference in structure, and that can have some important ramifications on how successful that agent is. So that can lead to a tool that doesn't exist being hallucinated, or that because there was an extra space or the grammar of the input of the tool was not correct, you get an error, and so on. So there's a lot of problems that can come up. And what we do at the framework level is we're kind of doing tricks to solve for these limitations of models. I think if the models themselves were more robust to these sorts of challenges, I think LLM agents would take off in a bigger way. And then I think the biggest thing that we're going to start talking about this year is the implications on safety, security, and privacy. I know my slide says what could go wrong, but actually these are concrete examples of what have went wrong for either people I know in the field or for my own team. So starting with this laundry list, unintentionally deleting your file system. So I've heard Graham Newbig, who leads the Open Hands project, say one of the first like agent instantiations they were playing with ended up deleting the file system on their laptop. So that doesn't sound fun. On my team, there was someone who was working on a patent filing and then ended up using one of our external experiments, and then unbeknownst to them, that data was sent to an external API, and we were able to resolve this, but that is also unideal. You might execute the wrong action, and sometimes you can't undo those things. Some sensitive data can be leaked. I've heard some news about this with some of the competition. And then these things can be vulnerable to prompt injections and malicious code. So these are all of things that LLMs are already subject to. But because we're giving this model access to an external environment and the autonomy to complete actions, this is where the risks get amplified. And I'm sure there's going to be a lot more thinking and guardrails around these sorts of aspects if we want to really make good use of this technology. Cool. So that was a high-level overview. We're going to switch gears a little bit and get a bit more technical on how do we program an LLM agent from scratch. So your first step is you have to select the right model. You have a lot of choices here. If you're going for something complex that might need multiple steps, where you have a couple of tools you want to use, you want to go for a big model that kind of responds well to chain of thought prompting. So chain of thought prompting was the precursor to why LLM agents exist today. Some people who were initially tinkering with ChatGPT found out that if I take the same query, so what's the fourth word in the phrase, I am not what I am, if you just ask directly, the model fumbles. But if you just add the magic words, think step by step, now the model gets the right answer. And there's a good analogy to how our own brains work. If I ask you a difficult math question, I tell you, you have 1 second to reply. I'm sure you're just going to guess something. But if you have more time to work through the answer, I'm sure you will be able to come up with the correct answer if I give you enough time. So kind of some models perform better at breaking down problems. So that's just due to what they've seen in their training data. And there's some benchmarks you can look at. I've written an article about what benchmarks you should be looking for, and I can link that in later. The second thing is defining the agent's control logic. So what you're seeing here is an initial diagram of what makes up an agent in the full sense of the word. So an agent that has control over the steps of the program. Important differentiation here. The difference between an agent and just a model that you prompt and get an answer right away is basically codified in the system prompt. For those of you not familiar with the term system prompt, it's basically a set of instructions that are fed to the model kind of in this background. So as a user, you don't see it. Like typical things that say you're a helpful assistant, you would always try to be friendly to users, etc. And then there's some extra things that we can put in the system prompt to basically tell the model, don't answer directly. No, think step by step. You have tools at your disposal. Use those tools to make up a really good plan on how you're going to solve this. When we talk about control logic, we're talking about kind of the paradigm of solving problems that you're telling the agent to follow. And there's a lot of schools of thought and debate on which one is better. If we're going to like simple to a little bit more complex, you have tool use. So tool use is basically telling the model, determine if you want to use a tool or not, or if you can like answer the question without using a tool. So it's kind of like a flow process. And there's some agency. The model can decide what tool to use and when. There's basic reflection. So you can get the model to generate a first answer, and then it can judge itself. So there's this critique step. Does the answer that that the model generated answer well the user query? And then it might update a few times until the answer gets better. There's React. So this is kind of one of the most popular architectures when it comes to building agents, but there's some thinking right now that the models that we have are actually not really great for React. So React is you first plan your first step, you execute it, you see the output, and then you decide if you want to iterate again. So it's kind of, you take one step at a time, you see what changes in the world, and then decide what's the next step you want to take. There's the plan and execute. So this is flipping that paradigm. So you plan all the steps ahead of time, execute all those steps, and then you can like compose a final answer. And what I'm observing in the field most times is people might start with something simple, maybe one of the first three here. And then depending on their use case, depending on some of what goes wrong, they might either add more things and make it more complicated or simplify. So again, how you translate that architecture into changing how the model responds is purely in this system prompt. And here, if I want to do something that is React-like, I've put here an excerpt of what that looks like for B. So it says you communicate only instruction lines. There's a specific format that you need to follow. And then if you go through the rest, it says, okay, like first you're going to get a user message. Then you need to come up with a thought. A thought is a single line step-by-step plan. Then you're going to input the function name. So the function name is basically the tool that you choose to use, what goes into that tool, the output, and then so on. And it takes some prompt engineering to get this right. That's why that's the benefit of using frameworks, is you have some building blocks you can work off of. Okay, so we talked about the communication structure. You still might know there's still some interesting things you can put in the system prompt, kind of like all the features you want your agent to have. Like what languages do you want your agent to know? What date and time format should it use? Should it use Celsius or Fahrenheit when giving temperature back? How should it greet users? What name does it have? And this is when you start thinking of your agent as a product and you want to give it feature specs. And all of these things can kind of be codified in through these instructions. So again, this is a quick excerpt. Like you can see in terms of capabilities, it tells it like what languages it can respond in, what capabilities it has, talks about like date formatting, what syntaxes it should respond in, and so on. And again, there's not a blueprint on how to do this up front. It's really based on like what is the problem you're trying to solve, how many users are going to be hitting this, and then how do you offer a good user experience for the people interacting with your agent. Okay, so there's a lot of steps. I think we're about halfway through. So step 4 is memory. So in order to explain what memory is, you have to bear in mind that models can only remember so many words at a time, and then they forget. So memory is a way of deciding how do you handle how many words and which words does the model remember. And remembering is really important, especially as an agent, when it's solving a problem, it has to remember a lot of things. It's going through multiple steps. It has to remember the outputs of all the steps to kind of synthesize to a final answer. Also, let's say if you're trying to do a personalized experience, so I don't know if some of you interacted with the ChatGPT and they introduced a memory feature where if you tell it certain facts about yourself, it kind of remembers you have a dog and what's your dog's name and what your hobbies are. So it gives you a more personalized experience over time. So if we're getting a bit technical here, there's a few ways on how to do this. So you can tell only keep the last X number of words and then drop everything else. Or if you want to be more sophisticated, you could say summarize all conversations turns so far, and then you could like forget the individual details. You can also use something called the long-term memory. So this is kind of where if you want to introduce like facts about someone, or if you have a kind of a database, or if you have if we're going back to that product info example, this is where all that information could be stored. Okay, then 5th step is the tools. So we introduce tools as what gives superpowers to your agent. It's basically all the complementary capabilities that the model on its own can't do super well. So you kind of codify them and you tell the model you have access to them. So if you need to delegate certain tasks to these tools, you can do that. And tools take a few things into consideration. So first, you need to give your tool a name. And from our experience, you actually need to go with an intuitive name. If you name it something obscure or like, I don't know, some, just like some different capital letters together, the LLM might not do a good job at selecting that tool when needed. So for example, one learning we have with the OpenMeteo tool was our agents wasn't doing such a good job at selecting it. And when we changed the name to weather tool, it did a better job. Next thing is description. So this is actually, the description is not for the end user, it's for the LLM to reason about whether to use that tool or not. And usually the descriptions would be a couple of sentences, and you could do some prompt engineering here to help the agent succeed in calling the tool. You would also define what inputs the agent needs. So some tools require, if you're if you're interacting with the HR system, it might require you to provide the name and the email and something like that. So all of these informations would be needed. And what the agent does is it translates vague user input into the hard requirements that need to go into these tools. And then finally, the tool has to run somewhere. This needs to be defined. And if you want to go advanced, then I think a lot of people going after production use cases, what they would do is they would even have error handling techniques. So let's say for that HR system, I don't know, there was a certain formatting requirement on naming. So you could catch those errors and get the model to self-debug and maybe ask for human input if required. But all of these things that you can do here that are extra can help increase how well the agent performs on its own. And this gives you an idea of like what tools are. And this is a list of tools that we have in B. So our most common and popular tool is Python. Python is very dynamic because it's just the ability to write code. And a lot of software is written in code, right? In Python. So it kind of allows you to generate dynamic things. And I'll showcase to you some examples here. Other tools, you can do web search with Google or DuckDuckGo. You might call another LLM. You might interact with different APIs like Archive or OpenMedio. You might want to interact with a vector database. So that's where Elasticsearch comes in. And there's so many things that you can put in here as tools. Okay, so now we kind of completed the picture. I think one of the last things in terms of the system prompt is you might want to give your agent a role. And there's certain papers that show that the agent kind of performs better when it kind of has a really well-defined and narrow role. And that's due to kind of the limitations of current models. It's often found that if you overwhelm the single agent with too many tools, with too broad of a scope, it's not going to do as well than if you give it a very small and defined scope. So an example is you're a data analyst agent. Your goal is to analyze data provided by the user and extract insights from it. Okay, so that was a lot to cover, but there is more. So let's say you get a user input in, and then the LLM gets all the way to a raw output. What do you do next? So a raw output is not something that is easy to handle when you're talking about programming. What translates this into a format that the application understands is a parser. So a parser can put this into a format where it's easier to automate and execute the next step. So based on the parse output, two things can happen. You could either see that the model recommended using a tool. So you could directly orchestrate to that tool being called, and then you kind of loop again here. Or it could be that you are 3-4 steps into the process. It looks like the model said this is the final answer, and then the orchestrator can provide the final answer here. So this is an example of a parsed output. So here there are kind of like key terms, so like thought, function name, function input, function output, etc. So all of these can be parsable by the program. And then, for example, when it recognizes function name equals Python, okay, that's the point where, okay, I need to use the code interpreter to run Python code. And then once it sees final answer key, that means return the final answer. Cool. So that covered just creating a single agent. But what is the state of the art so far? And that's mainly due to the limitations of models. Like I said earlier, it's best practice to not overwhelm a single model with single agent with too many tools, too much context, too big of a role. So what you do here is you design a system where you have different agents that have narrow roles all interact together. So this is an example of a multi-agent system that can generate a report based on doing some research, summarizing the research, critiquing the answer, and then kind of updating what it's going to research next, all the way so it can generate a report. So when you move to the multi-agent paradigm, there's a lot of operational aspects to consider. So one is, how do you ensure all the right information and context is shared between all the agents? Let's say agent 2 or 1 ran into an error. How do we get it to debug and kind of not impact the rest of it? So how do you minimize you having to intervene and debug the agent, and instead of it being able to self-debug? There's some looping here. How do you avoid infinite looping? How do you avoid not blowing $100 on LLM inference costs? And then how do you persist state? So let's say, for example, you're running this and for some reason, I don't know, electricity cut off while you're about to do step 3. Can I still save step 1 and 2 from memory and then kind of resume so I don't lose kind of the tokens I spent here to get step 1 and 2 done? And these are all of capabilities that kind of make it hard to build these systems, especially if you're getting to this level of complication, makes it hard to build it from scratch. And all of these are reasons why some people like start with frameworks. Another thing I wanted to call out is why I'm using the term multi-actor. Actually, multi-actor is a term that I think Landgraf introduced, and I think it reflects more, I think, where we're going to be going with these agentic systems. Some actors are going to be agents, like I showed you before, agents that have some control over how it executes the plan. But some, like I would argue, sorry, this is a screenshot I borrowed from some of our other colleagues working on Granite. I would argue that some of these other steps are not agents, and then they're just like LLMs with a prompt. So what I think is going to happen when we're doing these like multi-actor systems is that you're going to have some actors that are agents, some actors that are something else, and all of these are going to come together to solve more complex problems. Cool. So yeah, I've been hinting of like sometimes it's useful to use a framework, but not always. A framework can be useful first and foremost if it gives you abstractions that are easy to learn and easy to adapt to your use case. That's kind of like the first filter you're going to use. Then you're going to be looking at integration. So how can I bring in my own data, models, and systems? How do I observe everything? Observability is a really critical component, especially as you're building your system and trying to understand what goes wrong. You might want to look for, if you're trying to go to production, you're going to look for production grade capabilities, and then code examples and community support are a big boost here. I would say start from scratch. If one, you're building something really unique or cutting edge, and the abstractions that you're seeing in frameworks just don't work for your need or require too much customization, that's easier to start with a blank slate. Or on the other side of the spectrum, you're kind of just either prompting a model in very simple terms, or what you can be done is already handled by an API, and then you just can put some parameters into that API. And then, yeah, always go with what's simple when that makes sense. Okay, so that wraps up kind of what is an LLM, and it gives you all the tools to think about the components of an LLM agent. Next, I'm going to dive into Project B. This is a project that we've started working on earlier last year. And the starting premise is building these agentic systems is hard, especially this sort of system that I showed here, or the one that solves software engineering tasks. It's really teams of PhDs that are able to solve these things. So our whole ethos is how can we democratize how we build with AI? I'm sure there are like millions of developers out there that would love to get onboarded with Gen AI, and agents are the next paradigm. So how can we bridge the gap and make this more tangible for everyone? And that's when we introduced the B platform. So it was introduced later last year. So it's a truly open source platform for building agentic applications, and it starts from the framework all the way to a web UI. And we try to serve different users through this. So if you're an agent developer, I think the framework is going to be a good starting place. API is for integrators. So if you're building your own application, if you want to integrate APIs into there, that makes sense. And then we started on this journey of building a web app, thinking it would be for business users, but actually it's with pro code and developers that loved it a lot. And they were kind of telling us, don't delete it or don't deprecate it yet. It's really useful. And I'll be demoing some of that to you later on. So some of the highlights, so it's optimized for open source models. And by optimized, I don't just mean you're able to use like Llama or Granite with it. It means the whole system prompt and the whole way of handling tokens is optimized to work with these models. And that takes hard work. We have the best-in-class observability that you can have with an Apache 2.0 license. And then we have a lot of great production-grade controls there. So we actually had a different team working on an end-user application, and that was a great way of dog-feeding all of these different capabilities we needed to have to not just only build an agentic system, but have thousands of users hitting those agents at once without running into any issues. Cool. So yeah, all the components that I introduced before, so like agents and multi-agent workflows and tools, it's all covered. There's also additional capabilities for visibility. There's a code interpreter, so your file system doesn't get deleted if you're working with agents. And then all these extra capabilities that if you're trying to build something at scale, make it really helpful. So structured outputs, caching, error handling, and so on. We started in TypeScript. We have Python. We're working on bringing it to Python parity. I think in a couple of weeks that should be ready. I'll be demoing the UI. The UI, there's a lot of value, specifically from the side-by-side builder, which I'll be demoing next. And then I just want to take some time to talk about our ecosystem integrations. So you're able to kind of connect into any LLM provider that you're currently using, including the kind of self-hosted ones like Olama. In terms of tools, we have our own tools. We connect to the model context protocol from Anthropic. And from there, you can connect to a bunch of different tools like Slack and so on. And then any tools in LangChain, you'll be able to plug those in as well. Cool. So I'm going to be diving into the code approach next. And if I would recommend you could still follow along if you want to. All the code snippets are here at this URL. But this is also something that will be live after this session. And then you could always refer to that if you want to get started or recreate what you're seeing at home. Okay. So I'm going to open my terminal. Cool. So let me close the terminal so we have a fresh start to work off of. So just to orient you, I'm working off of, so there's the B agent framework here, which is a good place to get started. We also created a starter template. So this has like the kind of the minimum set of things that enable you to get started fast. And yeah, it's quite easy to run this. All you need is to clone this, and then I'll start showing you the capabilities from here on out. Okay. So let's open a terminal. Cool. So I'm kind of starting my node. What you will be doing in the meantime as well is you can plug in your environment variable. So basically, this is going to be your LLM inference key. In the docs I shared, there's instructions on how to get a free trial for Watson X, but you can also plug into any provider of your choice. Cool. So let's get started with the simplest script. So this is kind of a basic agent. It has token memory, meaning it's kind of going to drop the previous messages to keep only the maximum context window in context. It's based on a B agent. A B agent is basically a React agent that I introduced earlier. It has two tools, so weather and DuckDuckGo, so web search. And then these are kind of the extra controls that I talked about. So we kind of put some limits on how many times it can loop on itself, so you don't end up spending too much tokens. And then there's some observability capabilities plugged in. So let's start with like just making sure that my setup is correct. And yeah, the model is running in the background. So I'm just going to say hello. Okay. So I got a greeting back. I also got the thoughts. So that's also fun to look at sometimes. Now let's try to see if I can get it to call a tool. So I'm going to say, I'm going out tomorrow to walk around Boston. What should I plan to wear? Okay, so we're starting to see the thought come up. So determine what the user should wear. I need to know the weather forecast. Okay, so it kind of reasoned that it needs to use this tool. It then translated my kind of vague user query into, okay, this is the structured input that the tool needs. The location, Boston, the country, USA. I didn't have to include USA in my query. The model reasoned that makes sense that Boston is in the US. The dates, all of this information is included. It saw the output. And then I got my final answer. So for your walk around Boston tomorrow morning, you should plan to wear some warm clothing, including a heavy coat, gloves, and a hat, as the temperature is -10 Celsius. That sounds terrible. Okay, So now let's move on to the next one. Let's try to see if it can look up kind of up-to-date information. So being in Boston, I'm going to ask, how many championships did the Celtics win? Okay, so now it's reasoning that it might need to look on the internet and so on. Okay. It's taking some time to get the answer. I think in the meantime, I just want to see, because the last time I tried, ChatGPT got this wrong. Let's try. Okay, so it says here they have won 17 NBA championships. Let's go over. Okay, still seems kind of stuck. Okay. So it says it's 18, and then if I go on Wikipedia, okay, it says 18. So ChatGPT got it wrong because ChatGPT doesn't have access to up-to-date information. Cool, that was fun. So now let's try to shift gears and do some math. And we're still using the script, and the script doesn't have a code interpreter. So I just want to kind of run it to see what happens. So I kind of told it to like multiply two complex numbers together, and it says I'm not capable of doing this. So it declined to do it because it said I don't have a calculator. And that's we kind of prompted it to do that because models don't do math well on their own. You want them to use code. So how do I get it to use code? Well, I have a script here on how to use the code interpreter. Another word for it is the Python tool. And to use that, I actually have to start a container. So that's just easy. And then in the code snippets that I've shared, you have all the instructions on how to run this. So what I'm doing right now is I'm just starting the container where all the code is going to kind of run in a shielded environment. And this might take some minutes to start up. In the meantime, I'll just showcase that one of the reasons why like Python tool is versatile is because you can kind of prototype your tools inside of Python. So for example, this is a Python function that generates riddles and that interfaces with this riddles API. So this takes just like, I don't know, a few minutes to set up, and then I'm able to create a custom tool that runs in Python. So let's retry my last command, but instead I'm going to use the Python tool. Okay, so it recognized that it can use the Python tool, got the right number. Yeah, you can't get code wrong. Next thing is I want to try this custom tool, the riddle generator, to see if that works. Okay, so it recognized that it has a tool set up to generate riddles. It used that tool, and then I got my riddle. Cool. Okay, so I'm going to close down that container. And then I'm going to move on to something harder. So one other script you'll have here is a workflow editor. So this is a multi-step agent system that can generate scripts for you. So complex reports, kind of what I showed earlier. I'm going to start running that and then kind of explain what's happening under the hood. Okay. So it's asked me what topic I'm interested in learning. I kind of give it some input, translate that into topic, and now the planning agent is coming over. So kind of let's take a look at what I'm looking at here. This is a mermaid diagram for what we're seeing. So my input gets pre-processed. So this is a model that just says infer the topic based on the user's input. Then it goes to a planning agent. The planning agent is React-based. It has web search, and it has an unconstrained memory. Then, oops, missed the slide. Then it goes into another LLM. So this is not an agent, an LLM that just kind of writes and like synthesizes the content, and then there's some critiquing, and then you kind of get a final blog post. This might take some time to run, so these multi-agent workflows can take a few minutes, so I might move on to something else while that's running in the background. Yeah, still running. So while that's running, I just wanted to show you the web app and shift gears a little bit. So the best way to get started with the web app completely locally is going to our bstack repo, and with only a few commands, you can get everything up and running. And then this like setup script is really easy to guide you on like where to input all your API keys and that, and then you should be able to get to pull up everything on localhost. For this demo, I'm actually going to use the hosted app just because I'm live streaming and running everything on my old MacBook. So just for the sake of everything being stable, but everything that I'm showcasing here, you can run in localhost on an supposedly average machine. So what I'm showcasing you here is exactly what you're going to see there. It's just a hosted app. And I talked before about how Python is really versatile. So I can actually create an agent that helps build me tools. So yeah, this is kind of like the role that it's been given. And let's say I want to create something that interfaces with GitHub and gets information from the GitHub API. So let's start running that. Okay. So it's kind of now reasoning about my request. And then now the beauty of a UI is that all of this information is like neatly parsed. Okay, so I got a tool. It says it's a get repository stars tool. And now the cool thing about this agent, this is kind of a place to build them, but I can also test it. So try it out on. Okay. Cool. So it recognized that it can use the exact function that I created, and I got a right tool. So this is a really great way of like creating tools quite fast. I'm just going to check in if we got an answer. Yep. So that other multi-agent workflow I built, it kind of went through multiple processes in order to come up with this like really structured article that has sources and different things to pull on. And this is because like different actors collaborated together to get to that final result. Okay, that was nice. Next, I want to show you how you kind of automate something complex, still with a single agent. So this is an agent that is an expert at interacting with structured data. So what I gave this agent access to is a bill of materials file. And what I want it to do is create a management report and kind of create some visualizations for that. So let's see how that functions. So it first reasoned that it needs to look into the data and analyze it. So we can see the interim thought, the input, the output of that. And now it's reasoning again. So the data set contains information about material supplied. So kind of did a first level, high level overview of the data and said, okay, next I need to analyze the suppliers. So it kind of goes deeper on that. Then it runs into an error. So the supplier column doesn't exist. And that's because it's called manufacturing, not supplier. So this is really cool because some users might use synonyms, and then the LLM can kind of self-debug that, okay, I use supplier, but I actually mean the data says manufacturer, so same thing. And same thing for like cost. I tried to look at cost, it doesn't exist. What do I do about that? So this is kind of the power of React, of like, I'm able to come with vague instructions, not match, like I don't have to even like really match the data, and then the agent is able to reason through all of that. Okay. Guess that went into a bug. Sorry, I might have to post that again. This is still in beta. Okay, for some reason there's a bug here and that's not working like I was trying it out 15 minutes ago, but that's all right. We're running a bit short on time, but I just wanted to showcase some capabilities. If you're just getting started with the concept of agent, actually this agent builder is a really great way to get started, because like all you have to do is give your agent a name, quickly describe what you want it to get done, and then you can easily toggle between like what tools you want on and off. And you can also create your own custom tools like I showed you before. So in the link that I shared, there's like instructions here on like how to create your own research agent and data agent and all of that. I wanted to showcase to you an experimental concept that we've been playing with. How can agents build end user applications? So this is, I kind of gave this a prompt. I said, I'm a product manager from an open source project. I need a dashboard to show the leadership how well my project is going. And then I got this done just like in a few minutes. So what's cool about this is that it not only works for my project and it returns some stats, but for example, InstructLab is in another research project that we have, and it works for that too. So actually built kind of a scalable piece of like UI based on this. And let's say I want to add more features to it. The cool thing is I can just chat and do that. So let's say I want to add a bar chart. Okay, so this is going to take some time to render in the backend. What's happening is kind of an agent is reasoning about my intent. It might go through that. And then what's going to end up doing is just generating all the code. And then I get the UI hosted so I can get to interact with it. And then I can save these apps, I can share them. And we think this is a really interesting modality where instead of kind of designing software by programming the how, you can actually just focus on the what. I want to see a bar chart. I want to see that. And that gets translated into a code. And we think this is going to be a really cool modality. So let me go back here again and see if that worked out. Yep, I got my bar chart. So that was really easy to do. So I'm going to start wrapping up. So back to the slides. And then quickly talk about what our roadmap and what's next. So roadmap, Python parity is coming soon. We brought in workflows. There's other patterns of how to orchestrate agents and actors. We'll be bringing that soon. We're going to do a little bit of an overhaul to our UI to make it more deeply integrated with the framework. We're going to be integrating into different agent frameworks and capabilities. And then being in research, we have access to cool ideas that we're planning on bringing those in. Also wanted to highlight that we love contributions and we love interacting with the community. We try to mark tickets that are open for contribution, and we'll be giving out swag. So please feel free to look into that. And then I don't know if we have time for questions, but while you're looking at this, I have 2 QR codes, one for a repo if you want to star it so you can reference it later. And then we have a Discord community. So let's say you take the instructions and go back home and you're trying to work your way through and you get stuck. The Discord community is a really great place to get feedback and like get yourself unblocked. Cool. Okay. I'm gonna try to see if I can take 1 or 2 questions. Okay. Is there something that one can do when building LLM agents to prevent prompt injections? Because as far as I know, LLMs cannot differentiate the user prompt and system prompt. That is when a prompt injection arises. That's a great question. So, I mean, prior to the agent kind of world, the prompt injections were still a risk. And some of the ways people were curtailing that is they had a kind of an input guardrail. So if there is any, and that could be like a simple classifier, like machine learning classifier, that it might be trained on some previous examples of prompt injections or known examples, and it might be able to generalize to new ones. But this is a fast moving space. So there's things that look innocuous that could still completely trip up an agent. So I think this is a place where like research needs to innovate. But still, I still think the concept of guardrails and input and output guardrails is helpful. And then I think a reflection step might give you additional assurances to be on the right track if something goes wrong. Another good question, how can you improve latency when running agents that need to talk to each other? So there's two things that are in kind of juxtaposed together or like trading off each other. Kind of the more time or the kind of the more search space you give an agent, likely the output is going to improve. At the same time, at the same time, it's going to cost you more and take up more time. So I think when you're testing out, you're going to try to understand for your use case, what's the balance between improving accuracy by 1 percentage point versus the cost of hallucination and the extra cost of tokens. For certain use cases, actually, the more you can like automate and the more you can improve accuracy, it's worth that cost because you're automating a high value task. But for others, you're just going to take in the fact that it's not going to be accurate and that might need a human in the loop. Another question, how can we ensure the reliability and robustness of LLM agents when dealing with complex stacks and real-world scenarios, considering the potential for hallucination and incorrect information generation in LLMs? This is a great question. I don't think this is fully answered by anything that exists out there. I think LLM agents, as of right now, are unreliable technology and don't provide consistent inputs. What we can do is we can do tricks. We do that in our own framework. One thing that we do is, for example, we force the model to follow a certain structured output. So if you remember previously when I showed you like kind of the raw and parsed output of the model where there's like a thought, an LLM tool, so we could constrain the vocabulary that the model can output so that it doesn't fumble on the output and like you're bringing in more structure. We can also make sure that it's not hallucinating tools. So there's all these tricks that we can do, but these are all tricks solving for models being an imperfect technology. There's a lot of people researching how to make the models themselves respond better to instructions. Because of the real reason and the real problem we have right now is that any instruction I give to a model, whether it's an agent or just a simple model, it's soft inputs, meaning the model might choose to follow if it's good at following those instructions based on how it was trained, but it's not a hard requirement. If we really want to go after mission critical systems, this is where I think the underlying technology needs to be better. And I do know, like in IBM and other places, there's a lot of thinking on how to get just the models themselves to respond better to inputs. All that we're doing right now is like limiting the scope of a single agent and doing tricks around the output and input. All of these are things that are curtailing the fact that this is not, that LLMs are imperfect technology. Cool. I only have a couple of minutes to spare. Thank you so much for tuning into this. The link for the code and everything to recreate this will be shared. And then please grab these QR codes. I think this is the best way to stay connected after this event. Thank you so much.